Why does Sierpinski gasket appear in Pascal's triangle? Imagine a simple triangle made of numbers. When you look closely at this triangle, something incredible happens. A pattern emerges that looks like a beautiful, repeating fractal shape. This shape is called the Sierpinski gasket. But how does this pattern show up in Pascal's triangle? That's what we are going to find out. Pascal's triangle is a triangle filled with numbers where each number is the sum of the two numbers above it. If you write out the first few rows, you will see the pattern grow. Now, if you focus on whether each number is odd or even, a surprising pattern appears. When you color all the odd numbers one color and the even numbers another, the pattern looks like the Sierpinski gasket. This is because the odd numbers from the filled parts of the fractal, while the even numbers create the empty spaces. This pattern happens because of a special property of the numbers called binomial coefficients. These are the numbers in Pascal's triangle. When we look at these numbers modulo 2, which means dividing by 2 and only keeping the remainder, odd numbers become 1 and even numbers become 0. When you do this, the pattern of ones and zeros creates the fractal shape. The odd numbers are like the filled-in parts, and the even numbers are the wholes. The reason this pattern repeats itself is due to a rule called Lucas's theorem. It explains how binomial coefficients behave when divided by a prime number, like 2. According to this rule, a binomial coefficient is odd if and only if there is no carryover when adding the row number and the position number in binary form. This rule creates the self-similar, repeating wholes that from the Sierpinski gasket. This connection between Pascal's triangle and the Sierpinski gasket shows how simple math operations can produce complex and beautiful shapes. It links the world of numbers, patterns, and shapes in a way that is both fascinating and visually appealing. This pattern is not just a coincidence but a reflection of the deep relationships in mathematics. It also has practical uses in computer science, especially in error correction and data encoding, where patterns like this help improve technology. So, the next time you see Pascal's triangle, remember that hidden inside are these amazing fractal patterns waiting to be discovered.